Okay, here we've got r sine alpha is 4 and r cos alpha equals minus 3. So we've got two equations in two unknowns. They tell us that r has got to be positive. But it turns out we don't want to know what alpha is. We want to know what r is. So when we saw something like this before and we wanted to know what alpha was, we divided the equations and we got tan alpha very quickly. Okay. If we want to not have to find alpha on the way to finding out what r is, there's a little trick we can do. Okay, if I square both of these equations, I'm going to get r squared sine squared alpha. And if I square the other one, that's going to give an r squared cos squared alpha. What I'm going to actually do, call them equations 1 and 2, I'm going to do equation 1 squared plus equation 2 squared. So I've got the left-hand side of equation 1 squared, but I want to add the left-hand side of equation 2 squared, so that's r squared cos squared alpha. And if the first thing was 4 and the second thing was minus 3, this must be the same thing as 4 squared plus minus 3 squared. Okay, I could have just written 4 squared plus 3 squared because I know that negative values become positive when you square them. Well, why have I done this? Because with the squaredy trig terms of sine squared alpha and cos squared alpha, if I take out the factor of r squared that I've created here, I've got a bracket of sine squared alpha plus cos squared alpha. Okay, and of course that's going to equal 16 plus 9 over here. But the point about this bracket is it just is 1. We found a sneaky way of getting rid of the alphas, because for any angle, the squaredy identity sine squared alpha plus cos squared alpha always equals 1. So we've got r squared equals 16 plus 9 is 25. So r equals, I'm going to square root, so I need plus or minus the square root of 25, which is plus or minus 5. But then we go back to the question which told us r is greater than 0. So we only need the positive solution. So we give our answer as r equals 5 since r is greater than 0, but we want to see that you've considered the plus or minus before rejecting the negative one. Okay, don't just lazily take only the positive square root without an explanation, because you could lose marks. Okay, so that's a little trick. This kind of situation, we're going to see it again quite soon, where we get r sine alpha and r cos alpha, and the easiest way to get r out of that is to use this trick of squaring and adding.